102.5 FM, KXSFLP San Francisco, and KXSF.FM.
You're tuned in to Spark, informing minds, inspiring ideas, igniting innovation. Let the conversation sink into your soul.
This is Kellee Marlowe, host of Spark. Today I'm talking with Robert Luo, CEO of Mi Terro, who has innovated sustainable fibers through spoiled milk. We will be talking about his innovative solution made from food waste that can replace fibers used in fashion as well as plastic in various industries. Thank you for joining me on Spark today, Robert.
Yeah, thank you for having me.
Tell us about what Mi Terro is, its mission, and the ProAct technology.
So Mi Terro is the world's first biotechnology company that creates ocean-degradable and home-compostable materials made from agriculture byproducts and surplus food. So what we do is that we're not turning agriculture byproduct into beverage or snack. Instead, we are turning it into advanced, novel, and high-quality materials that can replace plastic and cotton.
And how do you do that?
We have our own patent pending process. Step one, we call it ProAct, which means protein activation. We extract protein from agriculture byproduct or surplus food. Then we have to purify it into a good form that we can repurpose. The second step is called series self-assembly purification, which means we then purify these protein into good protein that's then re-engineered into either it's textile fiber or packaging material.
How can it be both a textile fiber, which is very different from plastic or packaging material?
So essentially, the first step, which I have described, is very similar. We extract the protein and purify it from different resources of agricultural byproduct or surplus food. The second step of turning into textile fiber is different from packaged material. For textile fiber, we implemented wet spinning process that spins the protein and working solution into the fiber. And for the packaged material, we cast and dry the working solution into the final packaging film that we're offering.
Okay, so it's the same polymer you're saying, but the way you are creating it, you can make it harder. So it's like plastic for packaging?
As for packaging, we're offering flexible packaging material. So it's not the hard, rigid form, but instead it's in the flexible film.
It's more of a film-like material that can be used in various industries?
Correct.
So currently, though, it's a textile fiber that you're working with to see what type of fashion or garment or textile products that can be made out of it?
Correct.
And then I see the line of T-shirt that's made from your milk proteins. Are you planning to expand into other textile product lines, or are you going to sell the actual polymers to the fashion industry for them to create fashion out of it?
We are looking forward to supply the fiber to other companies so they can create it into textile apparel line or other type of product that they desire to use it for.
And would it be more like cotton? What is the feel? Because, there's also people who are making leather out of shrimp shells and bags out of cactuses. In this case, how does the fabric come out from the milk protein?
The fabric has a silky touch. So it's very soft. It's great for innerwear, like underwear, t-shirt, tank top. It can also be made into baby apparel, which has a very high standard. It can potentially be edible if babies somehow chews on the shirt that's made from our milk fiber.
And there are benefits, right, in the fiber. And I'm curious where it comes from, because it says that it's breathable, it's odor-free. So can you tell me about the benefits and how it's derived from your fiber?
Absolutely. Inside of our working solution, we blend casein protein with other cellulose material. And cellulose material, they naturally have those antibacterial properties. On top of that, the amino acids inside of casein protein, which is also the milk protein, adds on to the softness, the the property that can nurture the skin. And that's why you feel the soft sensation, the soft touch when you wear it close to your skin.
And what about plastic? When you turn it into plastic, what will it be like and how can it be used?
So our flexible film will be home compostable. It's also ocean degradable, heat sealable, and potentially edible. At the same time, it has a great oxygen and water barrier, which makes it a great product for fresh produce, dry food, or even fashion packaging.
It's interesting that you can change it or repurpose a milk protein for two different types of materials. When will the plastic type of fiber be available?
We plan to start supplying in Q2 of next year.
Wow, that's pretty fast. What sustainable challenges will the ProAct technology address?
This will help substantially help us to upcycle these agricultural byproduct or surplus food, which was previously been disposed into landfill or treated as animal feedstock. We want to give these agricultural byproduct or surplus food a higher value that can potentially be used to replace, I believe, the biggest problem in the world, which is plastic pollution.
Because this is biodegradable, it'll address all the plastic that could be replaced by the milk protein fiber or polymer?
Right. Beyond milk protein, we can also use plant-based protein.
Oh, interesting. So it sounds like you'll try then to use plants instead after the successful run with milk?
Correct.
As I understand it, it saves 60% more water if you use this milk protein fiber versus using cotton.
Correct. Because we implement the spirit drying process that can recycle the water on the factory level. So the factory can actually reuse the water that's been repurposed from the liquid milk.
And it sounds like there are other sustainable solutions that your fiber is going to be creating for the environment. Can you talk about those benefits?
Well, aside from what you mentioned, that we're saving water, we're also reducing food waste. Also, I think it's a very big topic nowadays given the COVID situation. At the same time, we are, for our product, we plant 10 trees for every product we sell. And up to today, we have planted over 10,000 trees. We are very proud of this accomplishment. And we hope to give more impact to our environment as we move forward.
Can you talk about where the idea came from? I thought that was really interesting.
Yeah, the idea came after I visited my uncle's dairy farm in China back in 2018. I was first exposed to the unsold milk and the expired milk, spoiled milk that he had on his farm. It was my intention to help him distribute or sell or repurpose the milk waste that he had.
And how did you figure out to turn it into something else versus making cheese or giving it to people who need it before it goes bad?
Yeah, it wouldn't be the right idea or the first idea for anyone to think of using something from milk waste that's been spoiled. I have done a lot of research. I also spoke with my childhood friend Daniel, who I know has material science and chemistry background. So then we started to figure out what's inside of milk that's useful, that can be repurposed, and also that has a good quality, which people can perhaps wear on too close to the skin.
So you could just throw, let's say, the T-shirt line that you have created, you could just toss it into the compostable basket when you're done, rather than the garbage can, right?
Mm-hmm. So for the textile fiber, it can be industrial compost. So it does definitely need the right facility for it to compost.
That's amazing. And can you do that with the plastic products that you're creating?
Right. With the plastic product, we went even a step forward. We want it to be home compost. That means if you to bury it in your backyard in the soil, it should degrade within 6 months to a year.
But then is it still strong enough to do what it needs to do?
Absolutely. Because for it to degrade, you need microorganisms in the soil. Also, you need the right humidity and temperature for it to happen.
I was amazed at how much milk is wasted every year. Can you talk about that?
Yeah. So from our research, excuse me, it showed that around 128 million tons of milk are being wasted every single year. And this figure was given before COVID-19. And I believe during the COVID-19 situation, the numbers skyrocketed all around the world. So we hope that our solution can provide value to farmers who were reluctantly going to dump their milk because restaurants or schools have been closed down.
So how are you getting your milk, though? How does it work? How do they get their spoiled milk to you?
Yes, so we work with farmers and milk plants where we co-locate our technology on site. So the milk waste are initially delivered to the milk plant and we process it on the plant, on site.
Oh, wow. So that means that you have multiple facilities depending on where the milk plants are based?
Yes, so we currently work with one facility, and that's been the facility has been helping us to create the powder, the protein powder, which can then be repurposed into textile fiber or packaging material that we're working on.
So my understanding is that with these milk protein fibers or polymers, they're going to be able to replace petroleum-based fibers in terms of clothing and other products, right?
That's our ultimate goal, is to replace petroleum products.
What industries will you be creating for?
For textile fiber, it's mainly for the fashion industry. As for the packaging material, this can apply to the CPG industry, the food industry, even for the fashion packaging as well.
Where do you see the future of wasted food and what can be created from it?
Well, I see that so far, the majority of innovation in food or ag tech has been focused on genetic engineering, plant engineering, mechanical engineering, or even computer science. And there's still a lot of room to innovate using materials like biomaterials or nanomaterials. And for us, we want to turn agricultural byproducts and surplus food into plastic alternative solutions and other applications that can prevent more food from going to waste.
It sounds like you'll be focusing on other foods besides milk proteins then?
We're going to expand to plant-based, also vitamin supplement byproduct as well.
Interesting. What are vitamin supplements, and are they just supplements that are dated?
What I mean by vitamin supplement byproduct is whenever we produce something, whether it's a beverage, whether it's vitamin, there will always be byproduct from the process. So we can take those byproduct and turn it into the ingredient for our packaging material. So
would the proteins be different in these cases if where it's coming from a different source?
The protein will be slightly different, but what we care is about the amino acids inside the protein.
And that's what's helping to create the polymers that you need.
Yes, correct.
But there must be certain foods you can work with and certain foods that you can't?
We have been experimenting with spent grain and also soy protein. As for our new packaging material, we're also experimenting coenzyme Q10 from vitamin production.
So it sounds like there's a lot that you can work with from a food standpoint, and then turn around and perhaps create different types of fibrous products. How do you plan to scale up?
I would say that this is an advantage that we have over other bio-based material, is that we can source our raw material globally at a very low cost. And we also work with farmers, food processors, to help them reduce their disposal cost, because they actually spend money to dispose all these byproducts that they don't even use. And the reason, given that our final material can have a similar price as LDPE, which is currently the most widely used flexible packaging material in the world, which means our material can be 3 to 5 times cheaper compared to other bio-based materials such as PLA, PHA, or PBAT.
And there's nothing toxic, there's no downside or negative effects?
It definitely can be toxic, because this has to be a food-grade packaging material.
Now, the reason I ask is, there's always a negative that balances the positive. So are there any negatives that balance the positive here?
As far as we're thinking, we might use a little bit more energy if we have to dry the liquid food waste into a dry powder. That might be the most energy costing factor to the entire process. But other than that, there shouldn't be much negative downside from the process.
But does it take a lot of energy to do what you do?
As what I mentioned, if we're to dry the liquid food waste into the powder, it definitely takes energy, but definitely doesn't take more energy compared to making other type of bio-based materials.
Do you mind if I ask you, how is the company funded?
Yes. So we have been bootstrapped. Well, we bootstrapped until the early 2020, where we received a small funding from a Japanese angel. We have been making money from selling our own product. We also received grants and awards from competitions.
And the t-shirt line that you have on your website, is that a test or is that an actual product that you plan to expand on?
The t-shirt apparel line was our initial way of validating the market to show our clients that consumers will want this type of product at their home. But our main focus will be on B2B as we move forward to become a supplier to other big companies.
I think it's the first t-shirt line I've seen that's made from milk protein.
I'm glad to hear that.
Okay. So where can people get your clothing line or your t-shirts that's made from milk?
They can visit our website, www.miterro.com, MITERO.com.
Well, I can't wait to see what you are going to create in terms of sustainable fibers and what they're going to get turned into. It'll be an exciting journey to follow. Thank you for joining me on Spark today.
Thank you for having me today.